Hello everyone, welcome back to lecture 28. So, we were discussing about the landslide. So, this is the part 2. So, we have discussed about the landslide, what are the different parameters, and then we also discussed how we can classify the landslide based on the velocity, based on the mass movement. So, now we will continue this discussion and we will see what are the different types of movement, right. So, here the first one is the rotational landslide. So, here you can see this is the rotational landslide. The second one is the translational landslide, which is here. So, you can just compare these two, how they are different. Then block slide, this is the block slide where the movement is like this and this block is shifting, right. Then you have rock fall. So, here is the rock fall and the rocks are basically falling from a slope, right. Then you have topple. So, one particular section is simply toppled and you are having the fragments here. Then you have debris flow, it is coming with the flood, right. So, it is kind of flood when your material is oversaturated. Then debris avalanche, you have this debris avalanche, this complete thing is coming down. Then you have earth flow, here is the earth flow. So, here the velocity, if you remember, the based on the velocity we have characterized. So, this is slow. Then you have creep. So, here the simple normal displacement you will see, and this is very difficult to identify on the field, but I have a few photographs that will help you to realize how creep appears on the field. Then lateral spread. So, here you have the lateral spread, right. So, let us start with the rotational, which is also called as slump. So, here the block of material moving down a slope along a concave surface. So, here you can see this is making this concave surface. So, this is the main body, this is the surface of rupture and this is the slump blocked, right. And here you have radial fissures, toe, transverse ridges. Remember that what I discussed in the first slide, that everything is here, right. So, based on that you can characterize a particular landslide. This is another example from the field. Here you can see how the rotational landslide appears, right, and here you can see how it is happening. This particular animation is here to help you to understand how rotational landslide occurs, right. The next one is the translational. Block of material moving down slope that occurs along a distinctive surface of weakness. It can be soil horizon, bedding or fault parallel to the ground surface, right. So, here you can see this is parallel to the ground surface. So, this particular block has failed and it is going down, right. Again, here I have a video that will help you to see how translational landslides are happening, and here this is the photograph from field, right. So, here you can see how they appear. Then comes the block slide, it is under the translational. So, here a translational slide in which the moving mass consists of a single unit or a few closely related units that move down slope as a relatively coherent mass. The sliding mass remains relatively intact. So, here you can see how this is coming, right. So, this is intact, this is what I meant, right. So, this is from the field how this is happening. So, this is the example of block slide. Now, we will see rock falls. Unexpected release of rocks or coarse material from a steep slope. So, here you can see these rocks or the fragments of this rock that is coming down, right. Separation occurs along discontinuities such as fractures, joints and bedding planes, and movement occurs by free fall, bouncing and rolling, right. So, what happens if there is a, let us say this is a block, right. here you have a small crack. So, what happens? Water enters into this, and when the temperature is below the freezing temperature, then this will freeze, this water will freeze, and that will exert the pressure, right, because volume will change, and because of that these two blocks will be pushed away from each other. This happens for quite a long time, and then slowly this particular piece of rock that will start falling. So, this can fall, right. So, then you will have the free fall, or maybe bouncing, or maybe rolling. This kind of activities happens, right. Influenced by gravity, weathering, and the presence of interstitial water. So, interstitial water means the water into the pores of these rocks, and because of the temperature that will change the volume, and then slowly that will generate the fracture, and then this rock will start falling. This is the example of rock fall. Here you can see the video. So, this particular rock is falling, and this is in the field how they appear. So, this can be smaller in size, and this can be very large in size. Then comes the topple, similar to falls and distinguished by the forward rotation. So, this is similar to fall, but what happens here, it will be toppling, mass movement of rock or debris out of slope. Here simply this particular chunk, this was here, right, and this has come down because of the gravity, it has towards the forward rotation. So, this is forward rotation is very important, caused by gravity and forces exerted by the adjacent unit or by fluid in the cracks. So, as I told you in the previous case, the water enters, and because of the change in the temperature, this will be weakened, and then this particular rock will fall. Then comes the topple. Here this is the animation of the topple. You can see how it appears, and in the field how they appear, right. The next is the debris flow. So, here a mass of loose water laden or poorly sorted debris that flows down a slope, right. So, here you can see this particular material will flow down, right, triggered by heavy rainfall, rapid snow melt, or other landslides. Rapid mass movement contains fine materials. Influenced by gravity, mechanical weathering, and the presence of interstitial water. So, here in the field how they appear, this debris flow, this is the damage. You can just try to understand how devastating it could be. So, this is the animation you can just see. So, you will be able to understand how it is happening because of the heavy rainfall, this is happening, right. You can see again. Now, we will see the creep, which I told you that the velocity is very low and it is very hard to notice in the ground, right. So, very slow downward movement of slope forming soil or rock. Movement is caused by shear stress sufficient to produce permanent deformation, but too small to produce shear failure. So, here this is permanent, the damage is permanent, right. So, the deformation is permanent, but it is very small to produce the shear failure. So, seasonal creep you have where movement is within the depth of soil affected by seasonal changes in soil moisture and soil temperature is called seasonal creep. Now, comes the continuous creep, where shear stress continuously exceeds the strength of the material. Then comes the progressive creep, where slopes are reaching the point of failure as other type of mass movements, and the creep is indicated by curved tree trunks, bent fences. So, as I told you, the velocity is very low and it will be very hard to notice, but there are a few indicators. So, creep is indicated by curved tree trunks, bent fences or retaining walls, tilted poles or fences and small soil ripples or ridges in the field. So, you will understand by looking at this particular diagram. Here you can see there is a change in the orientation, right. I hope you are able to see this angles. In the field you can see this kind of ripple mark can be seen. This is because of the creep landslide. Here you can see this video. We will try to watch this video. Here you can see how the creep is taking place, right. Now we will talk about the earth flow. So, here this animation also will help you. So, an earth flow is a type of mass wasting where fine grained soil, clay or silt moves downslope in a fluid like motion due to gravity. It is slower than debris flows, but can still cause significant damage caused by heavy precipitation, deforestation, earthquake, etc. Has a tongue shaped form with a steep scarp at the head. So, here you can see. In the field you will see this kind of feature when we talk about the earth flow. Then comes the debris avalanche. So, this is the extremely large and fast moving debris flow, right. Rapid, extremely fast moving mass of rocks, soil and debris that detaches from a steep slope and flows down slope in a turbulent manner, right. Often triggered by volcanic activity, earthquakes or heavy rainfall, and it is very fast. So, the velocity is very high, rate of movement is very high. Moves chaotically, often in a widening path, right. Debris avalanche. So, here this is, you can see the debris avalanche example here, how the material is coming down the slope, right. Then comes the lateral spread. So, when surface material extend or spread on gentle slope, this type of ground deformation is often associated with earthquake shaking. So, because of the seismic activity, this lateral spreading is taking place. You can see here. Ground failure, when cohesionless soil moves horizontally over a weaker underlying layer, often due to liquefaction, right, occurs in area with weak subsurface layers like soft clay or liquefiable sand. I will be covering this liquefaction in the next module, module 9, but here for time being you can consider when we talk about the liquefaction or liquefiable sand or soil, that means temporarily it is losing its stability, right. So, displacement in horizontal rather than rotational. So, here you can see this is the horizontal displacement. So, when we talk about the lateral spread, the displacement is horizontal rather than rotational. It commonly occurred on gentle slope or in areas with weak subsurface layers. So, this is how they appear in the field, right, lateral spread. Now, we will talk about the state of activity, where we will discuss stages of movement of a slope. So, the pre-failure stage, including all the deformation processes leading to failure. The onset of failure characterized by the formation of a continuous shear surfaces through the entire soil mass. The post-failure stage, which includes movement of the soil mass involved in the landslide from just after failure until it essentially stops. The reactivation stage, when a soil mass slides along one or several pre-existing shear surfaces, right. So, here this particular graph will tell you different stages of movement of a slope. So, this is the pre-failure, this is the first failure, this is the post-failure, this is occasional reactivation, and this is active landslides. So, here this is the time and this is the displacement rate, right. So, I hope you are able to understand this. Then when we talk about the state of activity, so here you have active, suspended, reactivated, dormant, abundant, stabilized, relict, and so we will see one by one all of them, that how they appear, what they mean, and how we will be able to identify them in the field. So, this is when we talk about the active landslide. So, currently moving, movement can be slow or rapid depending on the material and triggering conditions. In the figure, toe erosion causes a block to topple. So, basically here there was a erosion, right, which caused this particular block to topple. Then comes the suspended, moved in the last 12 months, and here it is suspended. So, you can see some amount of deposition is taking place, not active currently. In the figure, local cracking can be seen near the crown, right. So, here you can see some cracking. When we say reactivation, so this is the first block, then we had some deposition because weathering is taking place, then this particular block is now failing, right. So, it is failing from here to here. So, previously inactive, activated currently. In the figure, another block topples, disrupting the previously displaced material. So, now this will come on this particular block. Then inactive, not moved in 12 months, then it is divided into dormant, abundant, stabilized, and relict, right. So, here slowly what will happen? It is dormant. So, when we say it is inactive, and it can be classified into all these 4 categories. So, when we say dormant, it is basically inactive, can be reactivated by original or other causes. In the figure, you can see the displaced mass regains the vegetation cover and escapes modified by weathering. So, here the vegetation growth is taking place, right. This is the original one which is coming from here, right, and the vegetation has started growing here. When it is abundant, so it is again inactive, no longer affected by original causes because it has gained its stability on this particular slope. In the figure, you can see the fluvial deposition has protected the toe and the scarp regains its vegetation cover, right. Then comes the stabilized. So, either it will be naturally stabilized or it will be with some mechanism we are stabilizing these landslide. So, when we say stabilized, it is inactive, protected from its original causes by remedial measures, and here you can see a retaining wall is provided at the toe and soil nailing is done on the slope faces. So, you can see here, right. So, because of that it is getting stabilized. Now, the relict, it will be very hard even to identify whether any landslide occurred at this particular slope because there will be no traces here. So, this is inactive. Currently climatic and geomorphological conditions are considerably different from when it was formed, and here you can see uniform vegetation cover established here, right. So, it will be very hard even to notice that there were few landslide in this particular region. These are some of the references which you can refer if you are interested to know more about any one of them. You will be able to get the details from all these references. Thank you very much.